In order to understand water conservation by the kidneys, we have to take a look at the nephron, the parts of the nephron that are involved in water conservation. The nephron extends from the renal cortex all the way down to the renal medulla. The fluids in the renal cortex are at an osmolarity of 300. Now, 300 is the osmolarity of most of our body fluids. As we go deeper into the renal medulla, the osmolarity keeps increasing. So the deepest part of the renal medulla has an osmolarity of 1200. Here's a portion of the nephron involved. We have the PCT on top, followed by the descending limb of the nephron loop, the ascending limb of the nephron loop, DCT, and the collecting duct. The urine comes out of the collecting duct, and this urine will be either diluted or concentrated depending upon the situation. In order to understand water conservation, we need to apply 3 rules. Rule number 1 is that the osmolarity of the renal medulla increases as we go deeper. Rule number 2 is shown by these 2 red lines. It represents impermeability to water. The ascending limb of the nephron loop is impermeable to water. Rule number 3 is osmosis. Water follows the salt until it achieves equilibrium between the fluid inside the nephron and outside. Now let's apply osmosis to the descending limb of the nephron loop, which is permeable to water. Notice that at 600, water follows the salt and the inside of the nephron is also 600. At 700, the same thing happens. Water follows the salt and the inside is 700 and matches the outside. When the osmolarity is 900 at the renal medulla, more water leaves the tubule and the inside matches the outside at 900 until we reach 1200 and the nephron loop has an osmolarity of 1200. Now when we go up the ascending limb of the nephron loop, it is impermeable to water, so no more water leaves the tubule. However, there are pumps shown in black that pump out sodium chloride. This causes the fluid inside the ascending limb to become more dilute as you go higher. So we go from 1000 to 800 to 600 to 300 all the way to 100. 100 osmolarity is hypotonic to body fluids. So when the fluid enters the DCT, it is hypotonic at 100, whether or not we're dealing with a hot day or a cold day. On a hot day, we lose body fluids through our skin. To make up for this loss, the posterior pituitary releases a hormone called ADH or antidiuretic hormone. The antidiuretic hormone makes the DCT and the collecting duct much more permeable to water. As a result, water follows the salt as we saw before, and the inside of the tubule, the DCT and the collecting duct, becomes more concentrated. And the result is a small volume of urine that is produced, and this urine is highly concentrated. The opposite happens on a cold day because we don't lose as much body fluids through our skin. So the posterior pituitary responds by producing very little ADH or no ADH. In the absence of ADH, the DCT and the collecting duct become impermeable to water. So water cannot follow the salt, and the hypotonic fluid that arrived at the DCT is what leaves the collecting duct as urine. So we produce a large quantity of very dilute urine on a cold day because we don't have to conserve as much water.